Hi, I'm Xuneng. In this talk, I will share a practical path for getting started with Postgres hacking. And we will look at why Postgres hacking feels differently and how to start small and how small compounds over time. If you are interested in Postgres hacking, then this talk is for you. Okay, let's move to the title of this topic, The Hitchhiker's Guide to Postgres Hacking. It's all about hacking. And from this talk, we can learn that we should not be panic about Postgres hacking. We can just start small, and small will take we to where we want. Every journey into Postgres hacking starts with mixed feelings. There is excitement, curiosity, but there is also self-doubt, uncertainty, and confusion. And this is quite normal. From the outside, Postgres can look finished and intimidating. But from the inside, it is still a living engineer project where people ask questions, revise patches, and change their minds. Hacking Postgres is pretty hard, and this is why motivation matters. The codebase is massive and complex, so even finding where to start can be hard. And the review process is rigorous and hypercritical. And finally, the database technology itself is quite difficult. As we know, optimizers, transactions, and concurrency control, these are very hardcore technologies. Even it's hard, people still want to do it. And some people may do it for fun, because hacking is generally fun if you like logic, reasoning, and building large things from pieces. Some people do it for the community. If you make one small change, whether it's documentation or test, it actually helps all users. And sometimes people do it for profit because Postgres is the database for the future. Actually, these motivations are not mutually exclusive. You can enjoy the technical challenge, help the community, and build professional value at the same time. So, let's go on tour. The tour starts from a simple idea. Do not try to understand everything first. Start with something small enough to finish. Start small to build confidence and familiarity. One good starting point is reviewing patches. Reviewing patches help you generate ideas, learn the community thinks, and build connections with the hackers. Another starting point is fixing bugs. A small bug fix is usually self-contained and easier to follow. A third starting point is actually to test the features that other hackers work on. The common pattern is all three passes give you a concrete object to study. This patch, this bug, this test failure, or this behavior. So my first practical recommendation is start from reviewing patches. Contributing a new feature to Postgres can be hard. So begin by reviewing existing code. You get familiar with the Postgres hacker community. Learn explicit coding standards and learn unwritten communication norms. A useful review doesn't have to be perfect. You can report the patches builds, test the corner case, point out a confusing error message, or ask whether a behavior is intended. So how to get started? First, go to the Postgres mailing list page and subscribe to the hacker list. The hacker mailing list is the place that the hackers live, where the discussion happens and the debate happens, and the patches are reviewed. At the beginning, you don't need to reply to everything. Just read and watch how people structure arguments, notice what kinds of evidence are persuasive, test results, reproducible examples, and benchmarks with clear workloads. Then, pick a patch in CommitFest that interests you. CommitFest is the unique way of Postgres manage its review queue. Contributors submit patches there, and the reviewers help evaluate correctness, design, test, and code quality. Actually, you don't need to pick the largest patch. Just pick something with clear scope where you can say, "Oh, I understand what it's trying to do, and I can test whether it does that." The practical review workflow has 4 layers. First, build and test the patch. Usually, you can make a check. And secondly, you can check the behavior, usability, and error messages. Thirdly, sanity check performance and concurrency. Fourthly, review code style, architecture, and documentation. I think that the orders actually matters. Start with basic reality checks, then move up toward to design and maintainability. Build and test prove that the patch survives baseline reality. Run make check against the existing and new regression test. When you report results, be precise. Say which branch, configure options, and test command you actually use. If something fails, including failing test name and important error output. Next, you can check behavior and errors. Ask whether the patch fulfills the original design or solve the original problem. Ask whether the API or command line interface feels intuitive, or whether it is overly complex. Look carefully at error message. Postgres should produce clear and helpful errors. And this is actually a fresh reviewer can be useful. Try invalidate inputs, pondering values, and a different order than the happy path. Ask whether a real user will do and what happens when they make a mistake. Then you can look at performance and concurrency. For performance, you can look for algorithmic bottlenecks and inefficient memory handling. Use benchmarks and tools like perf when change is performance sensitive. For concurrency, you can audit shared state, lock durations, wake ups, and deadlock logs. For a database, performance and concurrency are part of the correctness in practice. Even if you cannot do a full benchmark, ask what hard path is and what shell state the patch touches. Finally, look at architecture and the documentation. Ask whether the logic belongs to this layer. Ask whether the function or module and whether the text exercise the new behavior. Documentation also matters. Undocumented code becomes legacy code at the moment it merges. And architecture review is difficult because it requires taste and context. But you can still start with simple question. Is this duplicating an existing mechanism, or does the test describe the user behavior? Does the documentation explain the semantics? Okay, now I want to move from general advice to one concrete review journey. This journey starts with broadening the mailing list. The topic was implementing waiting for else and replay. At first glance, this is a very specific feature, but it's a good example of how a small review path can lead to real Postgres internal workers. So in the second half of the talk, I will use this example as a guided walk through how review becomes learning, and we will start from the user visible problem, then look at older pooling solution, then look at why pooling is more expensive than it appears, and finally look at how feedback from other hackers changed the design of the command. Okay, the problem that this patch and feature try to solve is read after write consistency in asynchronous settings. Imagine a user write a comment to the leader, gets an insert success, then reads from the follower. Because replication is asynchronous, the follower may not have replayed war records yet. So the read can return no results even though the write has actually succeeded from the user's perspective. In this diagram, the user inserts a comment, the leader accepts the write, and the later read is routed to the follower. If a follower is behind, then the query can miss the row. The database may be behaving correctly, but from the user's point of view, it looks like the system lost the write. Here is the basic architecture of streaming replication. On the primary, the backend modifies the table and writes wall. The wall sender sends a read wall and sends it to the replica. On the standby, the wall receiver writes the wall and the startup process replaces it into the table. But in asynchronous settings, the backend can return success after wall has been flushed locally, but before the standby has replayed it. This means there are several different positions to think about LSN positions: generated, sent, received, flushed, and replayed. These are related, but they are not in the same guarantee and at the same time. For read after write visibility on the standby, replay is the key point. Receiving and flushing wall is not enough. You need to waiting for the replay to let the table actually applies the record. Before wait for SN, the usual solution is pooling. The application obtains the target SN from the wall insert SN function on the primary. Then it pulls the standby using PG last wall replay SN to reach that target. This works, but it can be very inefficient. The attraction of pooling solution is that it's easy to implement outside the server. You do not need a new circle scan command. You also do not need to wait infra. You just write a loop. But the cost of that simplicity is paid repeatedly, and it pays in places that are not really part of the core problem. The core problem is only a comparison between the target SN and the standby's replay progress. Polling turns that into many SQL round trips asking the same question: have you reached this SN yet? The polling solution is quite simple. You get a deadline, repeatedly query PG last wall replay SN function. If the standby is not ready, continue. If the replay SN is greater than or equal to the target SN, return success. Otherwise, sleep and try again. The problem is that simplicity at the application level pushes repeatedly work to SQL execution, connection management, and the wake-ups at kernel level. And this overhead has two parts. First, every pooling solution at another query and compare SN. Then the system pays extra circle execution, connection, and network cost. Secondly, there is a latency versus load trade-off. Short pooling intervals give faster responses but increase the system overhead. Longer pooling intervals reduce this workload but increase the latency. The myth is that the polling is cheap because the wall replay LSM function is just a simple metadata read. Actually, the reality from low level is quite different. In the profile here, we can see that the actual SN check accounts for only 1.6% of the CPU time. And the remaining cost is the machinery around it: peer, PG circle, SPI, the executor, and the kernel wake-ups. The primary drivers of overhead are not the LSN comparison itself. There is interpreter tags, SPI plumbing, plan validation, snapshot work. This is why a server-side wait primitive can be much cleaner than the client-side polling. The detailed CPU profile makes this visible. Other functions take much more time than the actual PG wall replay function work. And that is the key point. The useful check is small, but the repeated execution framework is quite large. With wait for SN, the flow is more direct. First, update the primary. Second, capture the word insert SN. Third, on the replica, wait for that SN. And fourth, after success, itself to read because the change is actually replayed and visible on the replica. The application expresses the real intention. Wait until this word position has reached. The SQL example looks like this. On the primary, update the movie table and then call pgcurrent or insert sn function to capture the sn. Then, on the replica, run wait for sn as with the specific sn you captured from the primary. When it returns success, the application can read from the replica, knowing that relevant change is visible. After wait for SN, the system avoids the actual expiration evaluation cost of repeatedly pulling. It avoids high-frequency clock checks in the application loop. Instead, the backend can wait and sleep using the server's own wait infrastructure. The intention is simpler, and the resource behavior is actually better. The point is that waiting for replication progress is already a database state transition. The server tracks the relevant progress, so the server is the right place to wait efficiently for it. As we can see from the hardware matrix show, in this workload, pulling or waiting for target replay SN is occurs at about 10 seconds interval. And the PG18 pulling pass uses much more CPU work than the PG19 waiting pass. As we can see, cycles about 10 times higher, instructions about 5 times higher, and the catch misses about 7 times higher. And the task clock is about 3 times higher. And with PG19 wait for SN infra and the command, we actually reduce the numbers significantly. And this reveals that removing pooling removes a lot of repeated machinery. For review, this kind of evidence is powerful because it connects design to measurement. It gives other hackers something concrete to evaluate and challenge. It's also important to describe the workload honestly. But it also shows that shape of the cost. The polling pass repeatedly pays for general SQL machinery, while the waiting pass avoids much of that repeated work. So you need to write emails to explain and summarize this clearly. But the technical side idea is only part of the story. A Postgres hacker also changes through feedback. Actually, the reviews from the other hackers of the community helps the patches from very close state into the state that can be committable. So the next part, we're talking about how to take in feedbacks from others help shape the patches that we are working on. One piece of feedback for this patch is that the command needs timeout and no hero options. And this actually makes sense because application need to control how long they are willing to wait, and whether a timeout should raise an error. But then the grammar becomes a problem, becomes a design question. What should the option list look like? And this is where the community feedback shapes the interface. What we end up to with this patch is using a common pattern in Postgres development. Is with the option list. And Postgres development may begins with a good implementation idea, but the review turns to better user interface. And the grammar matters because SQL syntax is long-lived. Once users depend on it, it becomes hard to change. So the project is very careful about names, defaults, and extensibility. Another design input from hackers for this patch was to add a mode option to support weaker consistency guarantee. At first, wait4sn only waits for replay, but hackers point out that some users may want wait for war to be received or flushed instead of fully replayed, and this is called weaker guarantees. And that can be useful for clustering systems or applications with different durability and visibility requirements. And this feedback changes the abstraction boundary. The command is no longer wait until visible on the standby. It becomes wait until SN reached a selected progress state. And this is broader, but is still bounded. So the command can be extended with a mode option. The patch supports waiting for an SN to be replayed on replica to achieve read after write consistency in asynchronous settings. But it can also offer less strict guarantees, such as waiting for word to be written or flushed on the replica. This keeps the main command general without inventing separate commands for each level. And this is actually a good example of being open to feedback without losing the original goal. The original goal was a read after write consistency. The feedback did not remove that goal. It actually clarified that replay is one mode among several useful waiting mechanisms. A better design can preserve the main use case while making room for adjacent use cases. Now, let's look at the syntax of the new mode. The syntax becomes wait for SN with mode. The default mode is standby replay, which waits for war to replay to the specific SN. Standby write waits for war to be written or received on the standby. And the standby flush waits war to be flushed on this on standby. And the last one, primary flush, waits for war to be flushed to disk on the primary server. So these are the lessons learned so far from my hacking journey. Start small, but aim big. Be confident and persistent, and be open to feedback. As the Paul quote applies here again, knowledge expands fractally. And from a distance, its edge look quite smooth. But once you learn enough to get close to one, they turn out to be full of gaps. So small work can become big through compounding. So this is the end. Is this the end or the beginning? For Postgres hacking, I think it's always the beginning. Start with a simple review, a bug, a test, or small patch. Follow the discussion, learn the nearby code, let the knowledge compound. And most importantly, do not panic. Just small. Thank you.